Hare Krishna, dear students, welcome back. Now we have another very interesting problem. That's the 25th problem of the IIT JAM paper 2025. So here this question is also very straightforward, looks very compact, but it is not, again the solution is not that straightforward, to be honest. So if x comma y follows a bivariate normal distribution, which all of you know the standard notation, that is n2, then the mean vector, then the variance covariance matrix, and with this distribution you are asked to find the value of expectation of e power minus x into y. So one way is definitely taking the integral, right, and writing the joint PDF kind of thing and doing this double integral, but it might be little messy. So we will try to do it in another way, which is quite interesting and also quite conceptual, utilizes other results in joint distribution theory. So that is using the tool of conditioning. That is a very powerful tool. And for normal, since we know that conditional distributions of both y given x and x given y, we can compute conditional distribution, and from there we can compute conditional MGFs, and then we can compute marginal MGFs. So that is the trick, the set of tricks or rules or tools that we will use. So the first step is here. If you see, it is normal 0 0 1 row 1, where row is 0.05. So for bivariate normal, y given x follows normal row x 1 minus row square, and this row is half, so that means it is half into x, and this variance is 3/4. Now given x equal to small x, what we have, we want to compute e power minus xy. So you multiply small x because you are conditioning on x, and this follows again a normal where x square is inside as a constant. Now if z follows normal m comma s square, the MGF of an univariate normal, you all must be knowing the form, that is e power mt plus half s square t square. Here we have kind of a similar thing, right? So e power t x, but here we have e power minus xy, so t will be minus 1, and since x is a constant, treated as a constant over here because we are computing conditioned on capital X. So this is the expectation of e power minus xy. That is, upon simplification, equal to e power minus rho x square plus half 1 minus rho square x square. So what is going on essentially is you just put a t equal to minus 1 in place of m, you put this t is minus 1, and in place of this half t square s square is this part, t square is again 1. So you can write this whole thing as e power ax square, right, where a is this term. So it is now boiling down to a fairly simple form. So now I think all of you can understand what's the next step. That is, well, we have rho is equal to half, so you can compute a exactly by putting rho equal to half in the form of a, which gives you minus 1 over 8. So now again the thing is, e power minus xy is expectation of this thing, the conditional expectation. When again you take another expectation, the towering property, right? So that gives you the marginal expectation. The marginal expectation here is nothing but the expectation of this quantity. And for normal, where we have, because the marginal of x is normal 0 1, the marginal of y is also normal 0 1, so you are taking this with respect to normal 0 1. For normal 0 1, expectation e power ax square has this special form. Well, you can either remember this formula or there is a trick. This is again the MGF of x square, which follows chi square 1 at t equal to a. So this is it. this is the form, and in this form you can immediately understand this is where it comes from, where if you put a equal to minus 1 over 8, you get this kind of an expression, and this exactly matches with the option A, that is 2 by root 5. Hence this is the solution. So we are done, and I hope you enjoyed the solution. This conditioning trick is actually very useful in many of the problems related to joint distribution. So I hope it added some value to your knowledge box. So with that note, thank all of you. Hare Krishna. See you in the next video.